Welcome to chemistry classes. In this video we are going to discuss about grade 11 chemistry. Grade 11 chemistry states of matter. Okay, so here we have to discuss here states of matter. We know there are different states of matter. Solid state, liquid state, gaseous state. These are the different states of matter. Okay, so in this chapter we have to focus physical properties of states of matter. Okay, in we know there are different states of matter: solid state, liquid state, gaseous state, and we will focus on gaseous state. Okay, so here physical properties of gaseous state or physical properties of states of matter. Here in physical properties, first we have to discuss here intermolecular force of attraction. Intermolecular force of attraction. Actually, intermolecular force of attraction means force of attraction or force of repulsion, attractive force or repulsive force between adjacent particle. This force of attraction called intermolecular force of attraction. We know different states of matter: solid state, liquid state, gaseous state. All states of matter made up of extremely smallest particle. Solid state, liquid state, gaseous state, all states of matter made up of extremely smallest particle, small particles. Small particles may be atoms or molecules. Okay, and these small particles are tightly packed in solid state. In liquid state, particles are loosely packed. In gaseous state, particles are further apart. Okay, so in solid state, particles are tightly packed because intermolecular force of attraction is stronger. Okay, so here intermolecular force of attraction mean force of attraction, force of repulsion. Together we will say intermolecular force of attraction. Okay, here we have to focus on van der Waals force of attraction. Van der Waals force of attraction mean attractive force of attraction. We discuss intermolecular force of attraction mean attractive force and repulsive force, together intermolecular force of attraction. Clear? Attractive force called van der Waals force of attraction. Adjacent particles, there will be attractive force. This attractive force is called van der Waals force of attraction. There are different type of van der Waals force of attraction. London force also called dispersion force. London force or dispersion force. Dipole interaction, dipole induced dipole attraction, and hydrogen bond. We have to discuss more details about this. First, I will tell you which are van der Waals force of attraction. So, van der Waals force of attraction, dipole interaction, okay, London force also called dispersion force. Another one, dipole induced dipole attraction, hydrogen bond. Okay, also you remember different type of ions will be attracting each other. Ion attraction is not van der Waals force of attraction. Okay, a positively charged ion and negatively charged ion will be attracting each other. This attractive force is not van der Waals force of attraction. Okay, so I told you here these are the different type of van der Waals force of attraction. So let us discuss more details about London force. London force also called dispersion force. London force or dispersion force. Okay, this type of London force or dispersion force happening in non-polar molecules. Non-polar molecule. Okay, non-polar molecule mean this type of molecule. Here positive and negative charges are uniformly distributed. Okay, this type of molecules are called non-polar molecule. Their positive charge and negative charges are uniformly distributed. Okay, this type of molecule shows dispersion force or London force. Because of some external influence, this molecule became polar. Okay, because of radiation or lightning, this type of non-polar molecule became polar. Okay, became polar mean actually it was non-polar. Positive and negative charges are uniformly distributed. Because of some external influence, all positive charges came one side and all negative charges came to another side. Now it became polar, and this is temporary polar molecule. Okay, this is temporary polar molecule, and that's why this London force or dispersion force is a weak force of attraction. It is temporary force. This polarity only for short life. Okay, only for short period. That's why it is temporary force and it is weak force of attraction. Now see here, this is one non-polar molecule. Because of some external influence, it became polar. Okay, it is temporary polar molecule or temporary polar atom. Okay, so this temporary polar atom or molecule, it will induce polarity. Actually it is one non-polar molecule, it became polar, it is temporary polar. Here near to this temporary polar molecule, there is another non-polar molecule. Okay, because of this polarity, this non-polar molecule will induce polarity. Induce. Here this molecule induce polarity. You can see here. Okay, so here induce polarity. Okay, here actually this is non-polar molecule. Because of some external influence, it became polar. It is temporary polar molecule. This temporary polar molecule induce polarity on non-polar molecule. Induce polarity mean actually it is non-polar molecule. Because of this molecule, all positive charge, see here this is negative charge, so positive charge come to this side and negative charge go away from this side. Okay, now this is induced polar. Now both are temporary polar molecule. And this type of attraction here, these two temporary polar molecule will attracting each other. This type of attractive force is called London force, or we can say dispersion force. Okay, so these are the things you have to understand about dispersion force or London force. Here we discuss this force of attraction happening in non-polar molecule. Okay, a dipole will be developed. Okay, here this is dipole, or you can say polarity is developed by external influence, or dipole is developed by an external influence. Okay, and this dipole is short lived, and that's why it is temporary polarity. That's why it is very weak force of attraction. This short lived polar molecule will induce polarity in adjacent molecule, and that two molecule will attracting each other. This attractive force is called dispersion force or London force. Okay, and you have to understand another term here, another thing you have to understand here. See here, these two atoms or these two molecules will attracting each other. This interaction energy is directly proportional to 1 by r raised to 6. Two temporary molecule will attracting each other. This interaction energy is directly proportional to 1 by r raised to 6. Here r mean distance between two temporary polar molecule. R mean distance between two temporary atoms or two temporary molecules. This distance is termed r. Okay, so here interaction energy is directly proportional to 1 by r raised to 6. So these are the things you have to understand here. Dispersion force or London force. Dispersion or London force happening in non-polar molecule. It is very weak force of attraction. Okay, also you have to understand here interaction energy directly proportional to 1 by r raised to 6. Clear? Okay, so here we discuss dispersion force or London force. This is the first one. Next one we have to discuss here, second one, dipole-dipole interaction. The previous one, London force. London force means two non-polar molecule will attracting each other. It is temporary force. It is weak force. But next one we have to discuss dipole-dipole interaction. Dipole-dipole interaction means this force of attraction happening in permanent polar molecule like HCl. Here HCl, hydrogen and chlorine. We know chlorine, it is more electronegative atom. It has a partial negative charge. Hydrogen a partial positive charge. Partial negative charge, partial positive charge, delta minus, delta plus. Partial negative charge and partial positive charge mean partial positive charge and partial negative charge mean it is very small charge. Okay, the quantity of charge is very small, less than 1 electronic energy. We know 1 electronic energy mean 1.69 into 10 raised to minus 19 coulomb. This is 1 electronic energy. Here partial negative charge and partial positive charge mean it is less than 1 electronic energy. Clear? So here we are talking about dipole-dipole interaction. Dipole-dipole interaction happening in permanent dipole molecule, permanent polar molecule. Two permanent polar molecule attracting each other. This type of attractive force is called dipole-dipole interaction. This is strong force because it is permanent polar molecule. Out of van der Waals force of attraction, strong force is dipole-dipole interaction. After hydrogen bond, dipole-dipole is the first hydrogen bond is the stronger. After hydrogen bond, dipole-dipole is strong bond. Okay, compared to London force or dispersion force, here it is stronger. We know London force, it is temporary molecules and very weak force of attraction. Clear? Okay, so here another thing we have to understand here, interaction energy. Interaction energy directly proportional to 1 by r raised to 3. Interaction energy. Interaction energy means attraction between two adjacent molecules. This attraction decreases with increasing distance. Two molecules are far, so less attraction. Two molecules are near, so much more attraction. So attraction between two molecules will be decreases with increasing distance. Okay, so interaction energy here 1 by r raised to 3. The previous one, London force, interaction energy interaction energy directly proportional to 1 by r raised to 6. Here it is 1 by r raised to 3. Clear? Also it is permanent force of attraction, it is strong force of attraction, it happening in permanent molecule. These are the things you have to understand about dipole-dipole interaction. Next one we have to understand here, induced dipole attraction. Dipole and induced dipole attraction mean there is a permanent polar molecule, a permanent dipole molecule. This permanent dipole molecule induce polarity. This molecule permanent polar molecule, it will induce polarity on a non-polar molecule. Then these two molecules will be attracting each other. This type of attractive force is called dipole, induced dipole attraction. One is dipole, it is permanent polar. Induced dipole, actually it is non-polar molecule. This polar molecule will induce polarity on this molecule, then they will attracting each other, and this is called dipole, induced dipole attraction. Okay, compared to dipole-dipole interaction, this force will be less. Okay, less force. But compared to compared to London force or dispersion force, it will be stronger because one is polar molecule, one is permanent polar molecule. Okay, so this force is stronger than dispersion force and weaker than dipole-dipole interaction. Also here interaction energy directly proportional to 1 by r raised to 6. Okay, here interaction energy directly proportional to 1 by r raised to 6. So remember, if there is non-polar molecule, if there is any non-polar molecule, interaction energy directly proportional to 1 by r raised to 6. The previous one, London force, there is non-polar molecule, interaction energy 1 by r raised to 6. Here also one polar molecule and one non-polar molecule, so interaction energy 1 by r raised to 6. But here dipole-dipole interaction, two permanent polar molecule, so interaction energy 1 by r raised to 3. Clear? So here we discuss London force, dipole-dipole interaction. Also we discuss dipole-induced dipole interaction. Clear? Next one, here last one in this video, last point we have to discuss here, hydrogen bond. Hydrogen bond is strong force of, out of this strong force of attraction, hydrogen bond. Actually hydrogen bond means it is special type of dipole-dipole interaction. We discussed dipole-dipole interaction. It happening in a permanent polar molecule. HCl is example. Same type, hydrogen bond means same type. Okay, this is a special type of dipole-dipole interaction. Special type of dipole-dipole interaction. See here, hydrogen fluoride. The previous one we discussed hydrogen chloride. Similarly here, hydrogen fluoride. Okay, and here negatively charged atom will attract with positively charged hydrogen atom. Also here partial positive charge and partial negative charge. Here only the difference. Here nitrogen and oxygen, and fluorine. Negatively charged nitrogen, oxygen, fluorine, it will interact with electropositive hydrogen atom. Okay, here we will choose nitrogen, oxygen, fluorine because they have higher electronegativity. Okay, so these elements have higher electronegativity. They will interact with electropositive hydrogen and this attractive force is called hydrogen bond. So you remember here hydrogen bond is a strong bond and it is a special type of dipole-dipole interaction. In hydrogen bond, nitrogen, oxygen, fluorine, they will interact with the electropositive hydrogen atom and they form hydrogen bond. Okay, so these are the things we have to discuss here. So in this video we discussed states of matter. In states of matter we discuss intermolecular force of attraction. Intermolecular force of attraction means force of attraction and repulsion together we will say intermolecular force of attraction. Van der Waals force of attraction means attractive force called Van der Waals force of attraction. There are different type of Van der Waals force of attraction. London force, dispersion force. Another one we discussed dipole-dipole interaction. Then we discussed dipole-induced dipole interaction. Then we discussed here hydrogen bond. Okay, these are the things we have to discuss in this video. Next part we will discuss next video. So thank you for watching this.